Hello and welcome everyone to Sciencera. Water is so familiar to us that it is easy to overlook its many extraordinary qualities. In this chapter, you will learn how the structure of water molecule allows it to interact with other molecules, including other water molecules. This ability leads to water unique emergent properties that help make water suitable for life. Hydrogen bonding. Water has a V-shaped molecule with its two hydrogen atoms joined to the oxygen atom by single covalent bonds. Oxygen is more electronegative than hydrogen, so electrons of the covalent bonds spend more time closer to oxygen than to hydrogen. These are polar covalent bonds. This unequal sharing of electrons in water's V shape make it a polar molecule, meaning that its overall charge is unevenly distributed. In water, the oxygen of molecules has two regions of a partial negative charge and each hydrogen has a partial positive charge. The partially positive hydrogen of one molecule is attracted to partially negative oxygen of nearby molecule. The two molecules are thus held together by hydrogen bonding. Emergent properties of water. Four emergent properties of water facilitate an environment for life. These are cohesive behavior, ability to moderate temperature, expansion upon freezing, versatility as a solvent. We are going to look at each one separately. Cohesion of water molecule. Cohesion occurs when water molecules form hydrogen bonds with the water molecule holding them together. So, cohesion occurs between two water molecules. Cohesive forces are responsible for surface tension, a phenomena that results in the tendency of liquid surface to resist rupture when placed under stress. Water molecules at the surface at the water-air interface will form hydrogen bonds with their neighbors, just like water molecule deeper within the liquid. However, because they are exposed to air on one side, they will have fewer neighboring water molecules to bond with and will form strong bonds with neighbor they do have. Surface tension causes water to form spherical droplets and allow it to support the small objects. Addition of water. Addition is the attraction of molecules of one kind for molecules of a different kind, and it can be quite strong for water, especially with other molecules bearing positive or negative charges. For instance, addition enables water to climb upward through thin glass tube called capillary tubes placed in a beaker of water. This upward motion against gravity, known as capillary action, depends on the attraction between water molecules and the glass wall of the tube. Between water molecule is cohesion. Between water molecule and another substance is adhesion, as well as on the interaction between water molecules cohesion. Why are cohesive and adhesive forces important for life? They play a role in many water-based processes in biology, including the movement of water to the top of trees and drainage of tears from tear ducts in corner of your eyes. A simple example of cohesion in action comes from water strider, an insect that relies on surface tension to stay afloat on the surface of water. Ability to moderate temperature. Water absorbs heat from warmer air and releases stored heat to cooler air. Water can absorb or release a large amount of heat with only a slight change in its own temperature. Water has a high heat of fusion compared to other substances. It is 80 calories per gram. This is the amount of heat that has to be added or removed to make ice melt or water freeze. Water high specific heat. Water resists changing its temperature because of its high specific heat. The specific heat of a substance is the amount of heat that must be absorbed or lost for 1 gram of that substance to to change its temperature by 1 degree Celsius. A calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So water specific heat is 1 calorie per gram. Water high specific heat can be traced by hydrogen bonding. Heat is absorbed when hydrogen bond break and heat is released when hydrogen bond forms. The high specific heat of water minimizes the temperature fluctuation to within limits that permit life. Evaporative cooling. Evaporation is transformation of a substance from liquid to gas. Heat of vaporization is heat a liquid must absorb for 1 gram to be converted to gas. For water, 540 calories per gram. As a liquid evaporates, its remaining surface cools, a process called evaporative cooling. Evaporative cooling of water helps stabilize temperature in organisms and bodies of water. Floating of ice on liquid water. Ice floats in liquid water because hydrogen bonds in ice are more ordered, making ice less dense. Water reaches its greatest density at 4 degrees Celsius. If ice sank, all bodies of water would eventually freeze solid, making life impossible on Earth. The figure on the screen shows ice crystalline structure and floating barrier. In ice, each molecule is hydrogen bonded to 4 neighbors in a 3D crystals. Because the crystal is spacious, ice has fewer molecules than an equal volume of liquid water. In other words, ice is less dense than liquid water. Floating ice becomes a barrier that insulates the liquid water below from the colder air. The marine organism shows here is a type of shrimp called krill. It was photographed beneath floating ice in the southern ocean near Antarctica. Water is versatile as solvent. It is also known as solvent of life. A solution is a liquid that is homogeneous mixture of two or more substances. A solvent is the dissolving agent of a solution. The solute is substance that is dissolved. An aqueous solution is one in which solute is dissolved in water. Water is the solvent in aqueous solution. Water is versatile solvent due to its polarity, which allow it to form hydrogen bonds easily. When an ionic compound is dissolved in water, each ion is surrounded by a sphere of water molecule called hydration shell. Suppose, for example, that a spoonful of table salt, the ionic compound sodium chloride, is placed in water. At the surface of each crystal of salt, the sodium and chloride ions are exposed to the solvent. These ions and regions of water molecule are attracted to each other due to their opposite charges. The oxygen of water molecule have regions of partial negative charge that are attracted to sodium cations. The hydrogen region are partially positively charged and are attracted to chloride anion. As a result, water molecules surround the individual sodium and chloride ions, separating and shielding them from one another. The sphere of water molecules around each dissolved ion is called hydration shell. Hydrophilic and hydrophobic substances. A hydrophilic substance is one that has affinity for water. A hydrophobic substance is one that does not have affinity for water. Oil molecules are hydrophobic because they have relatively nonpolar covalent bonds. Solute concentration in aqueous solution. Most biochemical reaction occurs in water. Chemical reaction depend on collision of molecules and therefore on the concentration of solute in an aqueous solution. Molecular mass is the sum of all masses of all atoms in molecule. Number of molecules are usually measured in moles, where 1 mole is equal to 6.02 times 10 to power 23 molecules, which is Avogadro's number, and the unit Dalton were defined such that 6.02 times 10 to power 23 Daltons is equal to 1 gram. Molarity is number of moles of solute per liter of solution. Effect of acid-base condition on living. A hydrogen atom in a hydrogen bond between two or more two water molecules can shift from one to the other. The hydrogen atom leaves its electron behind and is transferred as proton hydrogen ion. The molecule with extra proton is now a hydronium ion, though it is often represented as H+. The molecule that lost the proton is now a hydroxide ion. Though statistically rare, the dissociation of water molecule has a great effect on organisms. Change in concentration of H plus or OH minus can drastically affect the chemistry of a cell. Concentration of H plus and OH are equal in pure water. Adding certain solutes called acid or bases modifies the concentration of H plus or OH minus ions. Biologists use something called the pH scale to describe whether a solution is acidic or basic. Acid and bases. An acid is any substance that increase the hydronium concentration of a solution, and base is any substance that reduces the H plus concentration of a solution. A base or alkali, for example, sodium hydroxide or ammonium hydroxide, is a substance that forms many hydroxide ions when dissociated from water. Therefore, a base or alkali always has a low concentration of hydrogen ion and consequently a high pH of 7.1 to 14. The fewer the hydrogen ion formed, the stronger the base and higher the pH. On the other hand, an acid, for example hydrochloric acid or hydrosulfuric acid, is a substance that forms many hydrogen ion when dissociated from water. Therefore, an acid always has a high concentration of hydrogen ion and consequently a low pH of 0 to 6.9. The more hydrogen ions that are formed, the stronger the acid and lower the pH. pH scale. In any aqueous solution at 25 degrees Celsius, the product of H plus and OH minus ion is constant and can be written as concentration of H plus ions times with the concentration of OH, which is equal to 10 to power minus 14. The pH of a solution is defined by negative logarithm of H plus concentration, which is written as pH equals minus log H plus concentration. For a neutral aqueous solution, H plus is 7. Acidic solution have pH values less than 7 and basic solution have pH values greater than 7. Most biological fluids have pH value in range of 6 to 7. Buffers. The internal pH of most living cells must remain close to pH 7. Buffers are substances that minimize changes in concentration of H plus and OH minus ions in a solution. It does so by accepting hydrogen ion from solution when they are in excess and donating hydrogen ion to solution when they are depleted. Most buffers consist of an acid-base pair that reversibly combines with H plus ion. Bicarbonate buffer system. Buffer works by accepting hydrogen ion from solution when they are in excess and donating hydrogen ion to solution when they are depleted. In the bicarbonate buffer system, the chemical equilibrium between carbonic acid and bicarbonate act as a pH regulator. If H plus concentration in blood begin to fall, that is, if pH rises, more carbonic acid dissociates, replenishing the hydrogen ion. When H plus ion concentration begins to rise, pH drops. The bicarbonate ion act as a base and remove the excess hydrogen ion. Acidification. Acid precipitation is precipitation such as rain, sleet or snow that contains a high concentration of acids, often because of pollution of the atmosphere. When fossil fuels are burnt, they release oxides of sulfur and nitrogen. When these oxides combine with water in atmosphere, they form sulfuric acid and nitric acid, which falls as acid precipitation. This acid water flows over and through the ground and into lakes, rivers and streams. Acid precipitation can kill living things and can result in decline or loss of some local animal and plant populations. Normal precipitation is slightly acidic because atmospheric carbon dioxide dissolves into precipitation and form carbonic acid. Precipitation is considered acid precipitation if it has a pH of less than 5.0. The pH of precipitation varies among different geographic areas. The pH of precipitation in eastern US and Canada ranges from 4.2 to 4.8, with most acidic precipitation occurring around Lake Erie or Lake Ontario. Effects of acid rain. Acid rain is very harmful to agriculture, plants, and animals. It washes away all nutrients which are required for growth and survival of plants. Acid rain affects agriculture by the way it alters the composition of soil. It causes respiratory issues in animals and humans. When acid rain falls down and flows into rivers and ponds, it affects the aquatic system. It alters the chemical composition of water to a form which is actually harmful to aquatic ecosystem to survive and cause water pollution. Acid rain also causes the corrosion of water pipes, which further results in leaching of heavy metal such as iron, lead, copper into drinking water. It damages the building and momentum made up of stones and metals. This brings us to the end of chemistry of water. Thank you for watching. If you like my video, don't forget to subscribe.